Somewhere beneath the cold, gray waters of the North Sea, hidden under layers of sediment and geological time, lies a secret that Earth has kept buried for over 40 million years. A scar so vast, so precise, so unmistakably violent that scientists who first glimpsed it in their data couldn't quite believe what they were seeing. A circular wound in the ocean floor, ringed by concentric ripples of shattered rock, stretching nearly 3 kilometers across and sitting roughly 129 kilometers off the coast of Yorkshire, England. This is the Silverpit crater, and for more than 2 decades, it sat at the center of one of the most heated disputes in modern geology. Was it truly the ancient fingerprint of a space rock that had come screaming out of the sky millions of years ago? Or was it simply the result of slow, grinding processes deep beneath the Earth, salt deposits shifting and collapsing over millennia? Scientists argued, papers were published, and the mystery seemed to only grow deeper the more it was studied. In 2009, a major geological review concluded that salt tectonics, not a space impact, had sculpted this strange structure. For many researchers, that seemed to be the end of the story. But science does not close a case simply because a verdict has been reached. Armed with technology that didn't exist when this debate first began, a new generation of researchers has cracked the Silverpit mystery wide open. Their conclusion is as dramatic as the event itself. A massive asteroid or comet slammed into a shallow prehistoric sea roughly 43 to 46 million years ago during an epoch called the Eocene. The explosion that followed would have been unlike anything any living creature in the region had ever witnessed. And the evidence, buried patiently all this time, has finally been brought to the surface. Unlike famous impact craters such as Chicxulub in Mexico or Meteor Crater in Arizona, the Silverpit structure is completely invisible from the surface. It lies buried beneath the North Sea floor, concealed under multiple layers of sediment. The only way to see it at all is through seismic imaging, a technology that uses sound waves bounced through rock to build a picture of structures deep underground. When energy company researchers first produced those seismic images in 2002, the circular structure they revealed was immediately striking. There was a central depression surrounded by concentric rings, and eerily similar to what you see when you drop a stone into still water, and also similar to impact craters observed on the Moon and other planets. The initial announcement caused a sensation. Here, it seemed, was an impact crater hiding beneath British waters, waiting patiently for tens of millions of years. But the counterarguments came quickly. The North Sea sits atop thick deposits of salt, and salt behaves in unusual ways under pressure. It can flow, rise, sink, and create complex geological structures, structures that in seismic images can look suspiciously like impact craters. Without direct physical samples, without definitive mineral evidence that only an impact can produce, the debate remained genuinely open. The mineral evidence that finally settled the argument comes in the form of shocked minerals, specifically quartz grains bearing the unmistakable signature of extreme, instantaneous pressure. When an asteroid strikes the Earth, the energy released is so enormous that it fundamentally transforms rock at the molecular level. Quartz grains develop microscopic deformation features known as planar deformation features, or PDFs, that simply cannot be created by any other geological process. Salt movement, volcanic activity, tectonic pressure, none of these forces are powerful enough to produce this signature. Only the hypersonic violence of a cosmic impact can do it. When researchers recovered samples from the Silverpit structure, the shocked quartz was there, unmistakable and irrefutable. Combined with advanced seismic analysis and computer simulations modeling how an impact in shallow water would have behaved, the case for a genuine asteroid impact became overwhelming. Picture the world 43 to 46 million years ago during the Eocene epoch. The climate was warmer, lush, humid, and teeming with life. The region we now call the North Sea was a shallow, sun-dappled ocean. Early ancestors of horses and whales were beginning to evolve. Mammals were diversifying across a world still finding its post-extinction equilibrium. And then, without warning, something arrived from above. A chunk of rock or ice, possibly a kilometer or more in diameter, entered Earth's atmosphere at perhaps 20 kilometers per second. It punched through the air and hit the shallow ocean with a force that defies easy comprehension. The energy released was equivalent to millions of nuclear bombs detonating simultaneously. The water was instantly vaporized, the seabed rock was melted, thrown outward, and fell back as a ring of debris. The concentric rings we see in seismic images today are the frozen echo of that catastrophic rebound. The impact also generated an enormous tsunami, reaching heights of over 100 meters, taller than a 30-story building. Those waves crashed into ancient shorelines across what is now northern Europe, sweeping inland and reshaping coastlines in minutes. While this event was nowhere near the scale of Chicxulub in Mexico, it was still a regional catastrophe of enormous proportions, a reminder that Earth has always lived under the shadow of the cosmos. The Silverpit confirmation also demonstrates something important about science itself. The two-decade debate was not a failure. It was science working exactly as it should. Competing hypotheses were proposed, tested, and ultimately resolved not by authority, but by evidence. The shocked quartz samples that clinched the case are the kind of physical, testable proof that science demands. And the fact that new technology could revisit and resolve a question that older methods left open shows how scientific knowledge is genuinely cumulative, each generation building on what came before. Beneath the North Sea, the Silverpit crater will continue to sit in quiet darkness, unchanged as it has for 43 million years. The shallow Eocene ocean that witnessed its violent birth is long gone, but the scar remains, the signature of the cosmos written in rock, a moment of ancient violence preserved in geological amber, waiting for the right tools and the right minds to finally read the story it has always been telling. If you found this journey through deep time as fascinating as we did, please like this video. It helps more people discover content like this. Share it with someone who loves science or space. Leave a comment below. Does it amaze you that evidence this ancient can still be recovered and decoded? We read every comment. And if you haven't subscribed yet, please do and hit the bell icon so you never miss a video. We would love to have you with us on every journey.